Hi, I'm Gael Malone,
I'm Susanna Ball.
And I'm Tate Lueck. We're from the Episcopal School of Jacksonville.
and this is our solution to Problem A, kangaroo care.
Kangaroo Mother Care, or KMC, is an intervention aimed at improving outcomes among preterm and low birth weight newborns. This method, which involves skin-to-skin contact and exclusive breastfeeding, significantly improves a premature or low birth weight baby's chance of survival. Our task was to model the health of a preterm infant under KMC. We aimed to determine optimal skin-to-skin contact time between the mother and baby and the optimal feeding based on the baby's weight. We had a few initial assumptions to simplify the problem. First, we said that babies do not have any major health issues in the first hours after birth. Second, we said preterm infants are able to breastfeed. Third, we said that all KMC providers or mothers have the same ability to care for the infant. Fourth, we said that all infants receive optimal feeding for their age and weight. And fifth, if KMC is skipped for a day, the infant still receives optimal feeding from hospital staff or other caregivers.
Our model had 5 different variables. First, H was for health. The target would be a score of 1, which is 100% healthy. Second, C was for the KMC contact time with the mother. The target was an 8-hour minimum. Next, W is the weight of the baby when KMC begins in pounds. A is the amount of feeding the baby receives daily, which changes over time as a result of weight and is in milliliters. Lastly, T is time in days.
After establishing initial assumptions and variables, we created 3 equations to help model the interactions of KMC. The first is weight gain within the first 28 days. The second is optimal feeding, which is related to weight gain. And the last one is health. The coefficients in the health equation were found through experimentation on MATLAB and under the assumption that skin-to-skin contact time was more influential than optimal feeding. The T unit in these equations is days.
This is how we interpreted the H value or health result of our model. An H value from 0 to 0.3 meant that the baby was very sickly and had a high chance of mortality. From 0.3 to 0.6, the baby was relatively unhealthy. An H value from 0.6 to 0.9 meant that the baby was relatively healthy. And lastly, an H value from 0.9 to 1 meant the baby was very, very healthy and had a high chance of survival.
For the model simulations, we assumed that the baby weighed 3.5 pounds, and we assumed that optimal feeding was part of the care. With the first graph, we set the initial health score of the baby to 0.1, which is interpreted as a frankly sick baby. Our C value, which is the daily skin-to-skin contact time, was set at 10. As you can see, this became a logistic growth model, and the H value after the 28 days soared up to 0.8, which represents a frankly healthy baby. For the second graph, we started with a moderately healthy baby set at 0.6 health score. However, this C value we set at 6 hours, which is below the target 8 hours a day skin-to-skin contact ratio. As you can see, this resulted in a logistic decay, and the H value actually went down below 0.1, indicating that this baby's health has deteriorated. Unlike the previous 2 models, these 2 graphs convey what happens when certain days are skipped or the amount of skin-to-skin contact time isn't entirely consistent throughout all 28 days. For example, in this second graph, between the days 0 and 3, the skin-to-skin contact time was set at 1. This plummeted the health score of the newborn baby. And after the 3rd day, all the way until the 16th day, that health score was set at 8, which is the target time. As the graph shows, the baby started to recover, but not all. Then, we set the contact time to 10 between the 16th day and the 28th day. This conveyed a massive improvement in the baby's health. This first graph shows that even if KMC is not initiated immediately after birth, the effects of KMC can still pertain. In this graph, the initial health score was 0.1, conveying that the baby was already in a sick state. Then, for the first 3 days, the skin-to-skin contact time was set at 0. This almost essentially brought the newborn baby's score down to 0. After the 3rd day, the skin-to-skin contact time was set at 10. This showed massive improvements until the 16th day, when the skin-to-skin contact was then set at 9. Even when the hours were lowered, it still showed improvement, as it was still above the target 8 hours that KMC recommends. And the baby who started with a 0.1 score ended above 0.8. Overall, this model confirms the efficacy of kangaroo mother care. This equation for health models how reaching the recommended skin-to-skin contact time and optimal feeding can both contribute to increasing a newborn's health. That being said, it also shows the dangers of not reaching these recommended thresholds, as that results in a decrease in overall health. Overall, this model reaffirms the recent studies on KMC. Although the model did effectively display some of the interactions in kangaroo mother care between a low birth weight baby and its mother, KMC is such a complex practice, and an infant's health within the first 28 days is not directly a result of solely skin-to-skin contact and feeding. If there was more time, this model would have covered other areas like body temperature, resource availability, and also recognized the risk with skin-to-skin contact, like risk of infection. Health could also be subdivided into certain aspects like mortality rate and neurodevelopment. This model also assumes that the quality of care at every location is equivalent. A more complex model would take geographical region and socioeconomic factors into account to give ultimately a better result.
Here are some of the sources and studies we use to determine the values for optimal feeding and optimal skin-to-skin contact time.
Thank you for listening to our presentation.